All right, so in this video, we're on lesson 2, and we're going to be looking at some of the basic properties of exponents and logarithms. So exponential functions versus logarithmic functions. And basically, logs and exponential functions, they go hand in hand. So it's almost like an inverse operation of each other if you want to kind of think about it like that. But we have a couple of learning targets, so you can kind of look at those, but I'm going to kind of jump right in. All right, so a couple of things that you need to know is that you have something called a common log, and you have something called a natural log. All right, a common log is just a basic logarithm, and you're going to notice that on your calculator, you actually have a log button right here. So here's the log button, all right, log. All right, it stands for logarithm. All right, so, and then you also have a natural log, which is the ln. So we're going to see ln, and there's a button on your calculator for that as well. So we have the common log and we have the natural log. Now, when you read this, log 7, that's the same thing as log base 10 of 7. So it's almost like the most common type of logarithm that we typically deal with has a base 10. And base, remember, is like lower, okay? Like the bottom number. So this is a base 10. That's the most common one that you'll ever encounter. That's why it's called a common log. All right. So they don't typically write the base 10. If they write log 7, they assume that you know that it's going to have a base 10. All right, without them even writing it. It's kind of like 7 is the same thing as 7 to the first power. The 1 is understood, right? Same thing here. All right, well then the natural log, I don't know why they didn't put NL for natural log, but they abbreviated that ln instead. All right, so that's a natural log. Now, what you need to know about that is natural log is associated with E, all right, which E, remember, has a numerical value, 2.7-ish, right? So when you have the ln of 4, that's actually the same thing as the log base E of 4, all right? So again, they're not going to put log base E of 4 in most cases. They're going to expect you to know it, that if they say the ln of 7, well, then that's the log base E of 7, right, for example. Now, I want you to notice how I've been saying it, all right? I've been reading it how you're supposed to read it. So this little 5 right here is called a base. So when we read it, we say log base 5 of 12, all right? Log base 5 of 12, all right? Now, what I said is that logarithms and exponentials are somewhat of like an inverse operation of each other, right? So they definitely are having something in common. All right, so we need to know how to convert between the two forms, because depending on what you're trying to do, it may be more helpful to have it in logarithmic form, but it also may be more helpful to have it in exponential form. All right, so there's a little tip off to the side that I use to help myself. Left to the right equals the middle. Left to the right equals the middle. So when I'm looking at this, I'm really saying, like, if I didn't have equals 3 there, like pretend that that was not there, like let me cover it up, okay? If that was not there, I would be looking at this saying, okay, the log base 10 of 1,000 is what? Like, I don't know. How do you figure that out, right? Well, what you need to think about it is like, okay, well, 10 to what power gives me 1,000? And then you might be like, okay, well, 10 to what power gives me 1,000? Well, 10 times 10 is 100. 100 times 10 is 1,000. Oh, 3. So 10 to the third power is 1,000. So that's really what you're doing. So when they're saying it's equal to 3, it's because 10 to the third power is 1,000. And notice in exponential form, what do we see? 10 to the third power is 1,000. Left to the right equals the middle, all right? Well, then when we look at the second one, you're saying, okay, self, 4 to what power gives me 1? Well, 4 to the 0 power gives me 1. Left to the right equals the middle, all right? So that's where that's coming from. When we look at the third example, we have a fraction, but think about like properties of exponents and things like that. Turn that frown upside down, right? So 9 to what power gives you 1 over 81? Well, 9 to the second power gives you 81, but how do I make it flip, right? How do I make it 1 over 81? Well, I need a negative exponent. So 9 to the negative 2 power gives me 1 over 81. Again, left to the right equals the middle. Left to the right equals the middle. So again, if we look at number 4, left to the right equals the middle. All right, this is how we would rewrite it. All right, now I'm not going to do all of these because I want y'all to try some of them as well. All right, so if I skip down to number 9, left to the right equals the middle. All right, left to the right equals the middle. I'm rewriting it in exponential form, but I need to be able to go the opposite way as well. And my brain has a little bit of a tough time doing that. So I'm going to write something and then I'm like, okay, I got to check it with left to the right equals the middle because I get a little bit confused. All right, so when I'm looking at this, I'm like, okay, left to the right equals the middle. All right, so the log, so this would be the left, right? So that would be 4. So log base 4 to the right equals the middle. So the middle, left to the right, equals the middle. So 4 to the what? So 64. So left to the right equals the middle. So left to the right equals the middle. So it kind of still does the exact same thing, right? Left, not to the right, but left, right, middle. Okay, so it's a little bit different in how it's written, but that kind of gives you a general idea. So if I look at this next one, it would be the log base 5, left, right, middle. So 1 over 125 equals middle negative 3. So left to the right equals the middle. So again, it's easier for me to look at it kind of like reverse, left to the right equals the middle, and then it kind of stands out. All right, so I'm not going to do all of those problems for this video because I want y'all to be able to practice it in class, and then we'll go over them together and you can check your answers. All right, but that gives you kind of a general idea of how to convert between logarithmic form and exponential form. All right, and that's page 10 in your packet. So flip over with me to page 11, and you're going to see the inverse properties of logarithms. All right, so there's some properties of logarithms, and basically it's a placement issue. Okay, so you got to really pay attention to placement. So you have b raised. Notice that this is all an exponent. Okay, it's all an exponent. All right, so notice that this b and this b are the same. And notice that the answer is x. All right, so what that means is if I have this right here, this first example, 5 raised to the log base 5, then essentially that is 1. All right, so the property, if you have a number raised to a log with the base of that same number, then it's 1. All right, and then 1 times 4 is 4. Okay. So another example would be the third one, 8 raised to the log base 8. Well, it's an exponent, so guess what? 8 raised to the log base 8 is technically 1. 1 times 10 is 10, okay? So that's how you're working that, all right? So that's that property. But again, it has to be the same. So this is where somebody's gonna mess up. If you had if you had 5 times the log base 5 of 2. That is not the same thing. You cannot do that with this property. Why? Because this is not an exponent. All right, so notice the property. You start out with a value, right? Your base number, and then you have log with that same base number. Okay, so it has to be an exponent. So placement matters. All right, so let's look at the second property. The second property says if you have the log base of the same exact number as the base, then it's just x, like, or whatever that exponent is. All right, so in this case, log base b of b, if you can say that properly, is technically 1. 1 times x is x. All right, so when we look at this, log base 6 of 6, Well, those 6's are the same, so that's 1. 1 times x is x. All right. Now, that's like a basic problem, okay? So if I had the log base 2 of 2, then that is 1, okay, for example. All right, but we look at these last two examples, and that is not the case, right? All right, so those numbers are not the same. We cannot use it. So what you have to think is, okay, what can I do to make it a little different? What can I do to maybe manipulate the way it's written so that I can use these properties to my advantage, because I need to simplify it as much as possible. So in order for this to cancel out and become 1, this 8 needs to be a 2. Why? Because if it was log base 2 of 2, that would cancel and become 1, right? All right, but that's not the case. So then we got to think, well, what can I do to 8? Can I do something to 8 to make it a 2 with an exponent? Yes. What is 8? 8 is the same thing as 2 cubed. So I'm going to rewrite this problem as the log base 2 of 2 cubed to the x. All right. So I replace the 8 with 2 cubed. Why? Because 2 cubed is legit 8. All right. So the log base 2 of 2 cancels. That's just technically 1. But then I have like a power to a power. And what do you do when you have like a power to a power? Well, you just multiply them. So that's just 3x. All right. So let's look at the last example. Again, we're going to have to manipulate. All right, so because 81 is not the same thing as 3, so I've got to think, well, is there anything I can do with 81? Now, you may not know it off the top of your head, right? Because y'all aren't just doing these every single day of your life. All right, so we got to think, okay, well, 3 squared is 9, so that's not going to work. What about 3 to the 3rd power? Nope. What about 3 to the 4th power? Ooh, ooh, yes, it works, right? So we're going to use 3 to the 4th power. That's going to be what we manipulate it with. All right, so we're going to say the log base 3 of 3 to the 4th power, because that's the same thing as 81, to the x. The log base 3 of 3 cancels. That's just 1. 4 times x is 4x. All right, so that's how you can manipulate your problem. All right, so you have several problems to try at the bottom using these properties. All right, so we'll kind of show you a couple of those. I'm not going to do a whole bunch of them, but I want to show you a couple of them. All right, so let's see. So a lot of these, like this first one, you're going to have to manipulate it. This one, you'll have to manipulate it. This one should be easy because the numbers are the same. All right, this one, you'll have to manipulate it. And let's look at these two right here. All right, this one is going to kind of throw you off a little bit, and you could technically just type in your calculator log 1,000 and get the answer because there is a log button, right? But remember, this is the same thing as the log base 10 of 1,000. All right, so I'm using the property because I want to kind of show you the property. So remember, 1,000 is the same thing as 10 to the 3rd power. So I could manipulate this log base 10 of 10 to the 3rd power. And then the log base 10 of 10 is technically 1. 1 times 3 is 3. All right. Because it was just a common log, just log, right? Then technically you could have done this in your calculator. You could have said log 1,000, enter, and still got 3. All right. So, but I wanted to show you how the property worked. All right. So if you look at F, we have the ln. Remember, that's a common, not a common, a natural log. All right, so that is the same thing. Ln is the same thing as the log base e, okay? So we learned that on the page before. So we have the log base e of what? E to the 7, all right? So the log base e of e is technically 1. 1 times 7 is 7. All right, so those would be a little bit trickier. All right, now you can kind of look at these other examples at the bottom. So the log base 5 of 5, that should be easy. So what are you left with? This one you'd have to manipulate a little bit because you have 9 and that's not the same thing. So what would 9 be? 3 squared, right? So there are some things that you'll have to do with that to figure it out. Here, you just have to be careful about this 2. it's not an x squared. So we'll talk a little bit more about that in class, but think about how you can manipulate these problems. All right, so I gave you some examples, of course, at the top using the property. Now you're using those properties to help you with these problems at the bottom of the paper. All right, so if you flip over, there's some more problems up here at the top, right? All right, so again, you're going to have to manipulate some of them, okay? Some of them will just cancel out really easily. All right, so for example, this one you would have to manipulate because 16 and 2 are not the same, so you'll have to manipulate it. You know, here the log base 5 of 5 would cancel, leaving you with the 12, so that kind of helps you out there. Here, you're going to have to do some manipulation, so we'll kind of look at that in class, actually. Okay, and then we'll have stuff like this. Okay, so if we look at this one, E and then ln. Well, remember, ln is the same thing as the log base E. So ln, I'm replacing it with log base E of 5x. Well, what do we do when we have E raised to the log base E? Remember, as long as it's an exponent, that's 1. 1 times 5x is 5x. Okay, so I'm kind of doing more of those examples with you, but that's how that works. All right. On the bottom of page 2, you're learning about the change of base formula. All right. And this is how you can use and manipulate or type it into your calculator. All right. You'll notice that in your calculator, you just have a log button. It doesn't let you change the base. Now, if you have one of the black calculators, there is a way that you change the base, okay? And so on your calculator, you may have a log with a little box, and like it may let you change it so you can kind of play around with that, but most of our students have this calculator and it doesn't do that, all right? So if you have the black calculator, you have a little bit of an advantage there, but I'm gonna show it to you on here because that's the one that I have and what most of y'all do have. So with the change of base formula, it tells us, and these are a little bit trickier, so I'm going to kind of use those as a guide, but I'm going to use this example instead. All right, so it tells us that you take the log of whatever the number is, all right? So the log of 9, and you divide it by whatever the base is, so the log of 2. All right, so the log 9 divided by the log 2. So again, think about the base. Like if this is a base, think about a cheer stunt. All right, if you're doing a cheer stunt and you're the base, are you the one that's up or are you the one that's down? Well, the base would be on the ground and the flyer is the one that's up, right? So if the 2 is the base, then 2 is the one that goes down. All right, so the base down, bottom, all right, denominator. All right, well, now that I know that, I can just put that in my calculator. I can say n over d. Log of 9 over log of 2. And I get 3.1699. So 3.17. I'll round it to 2 decimals. Usually you do like 3 decimals though, okay? But that would be like a 0, okay, which is not necessary technically. All right, if I had an eraser, I would just erase it real fast. All right, 3.17. All right, so the same thing goes with these. And notice that the property can be with logs or it can be with ln's. It really doesn't matter, all right, your natural logs. All right, so either way is the same thing. All right, so if we look at a couple of these, I'm not going to do them all because you're going to try some on your own, okay? But if we looked at this first one, it would be the log of 50 divided by the log of 5. All right, so I'd have n over d. Log 50 over log 5. And it would be 2.431. All right, so I want to kind of refresh your memory on what you're doing. So remember, like at the beginning of this video, I said this would be like 5 to what power gives you 50? 5 to what power gives you 50? Well, I don't know. You know, well, 5 squared is 25, but 5 cubed is 125, too much. Well, if I put this in my calculator and said 5 to the 2.431 power, notice that I got 50.02. Now, it's a little bit off because what did I do when I got this answer? I what? Rounded it. So that's why this isn't exactly 50. It's because of rounding error. But really, I'm saying 5 to what power gives me 50? So if you can think about your exponents and how that would work with your answers, then that will help you at least kind of predict your answer. So if I looked at this one right here, 8. Well, 8 to what power gives me 12? Well, 8 squared is 64. So 8 to the first power is 8. So I know it's going to be 1 point something, all right, is what I'm going to end up getting. But I would use change of base. Log 12 divided by log 8. So in my calculator, N over D, log 12, log 8 in the denominator. And what did I get? 1.195 if I round it. So remember what I said, 8 to what power gives you 12? Not 2, because 8 squared is 64. Not 1, because 8 to the first power is 8. So we know it's close to 1 because 8 squared is 64. That's a whole lot bigger, right? But 1.195 would be the rounded closest answer. All right, so big number, but same thing, same thing. This one, you could technically, on both of these, just type them in your calculator because there's a log button, there's an LN button. Okay, so technically you could just type those in your calculator. All right, so that's it for this video. I'm going to do the next section with condensing and expanding on a different video. So try those problems in your packet. And again, we'll talk a lot more about these in class, but hopefully this video helps a little bit.